Let's add some files to work with. Since we are going to parse indent language, let's make indent file with an example. And let's start coding. It will be a function, a unit. Let's split source into lines. Extract a constant in upper scope and map lines into tokens. Each token should save line number because of error reporting, and it should store line content as well. Let's extract indentation and store it in token. Let's split our tokens into those that start with tab and into those that start with space, because we want to validate our indentation. Here I remembered that execution of regular expression can return null. And if that happens, I will have no indent here, I will have null. So let's make the missing ternary expression. I will use immediately invoked function. Reason being is because I want to have this variable that will store my match result, so I don't execute the regular expression twice. And I don't want to name this function, so I will use it anonymously right here. So if null occurs, I will have an empty string. Here I'm obviously not sure if match stores the matched string in index 0. So I'm using a quick independent node process, and I'm starting it just to check if match outputs the string in index 0. The point is, whenever you are not sure, instead of looking at documentation, which is also a good solution, you can quickly check it by invoking node. For those of you that are not familiar with regular expressions, kappa on the start of the expression means from the start of the string. /t is for tab, plus is for multiple occurrences, at least one, and $ is for end of the string. Let's do the same for spaces. And check if the regex is working. Filter empty line tokens. Idea here is to make a set of all indexes and remove one by one and see what's left. Since I don't have a range function and we are avoiding dependencies as much as possible, let's implement it quickly. How range function is working? You make an array of size A, so that's A call A. Then fill it with ones, because if you don't fill them, map won't work properly. Underscore is because we don't care. Every element is 1. We only care for index, and we return index. So we get array of indexes of length A. Now extract those reoccurring variables minimum and maximum, and let's test the range function. It's properly working, as you can see, right? So let's continue. Let's try to eliminate indexes that appear in tab and space index tokens. So take both arrays into an account and iterate it, and then remove each index from set. Let's find lines that use both tab and space for indentation, and throw an error if those lines exist. Here I can already see some errors in my code, but let's wait until I discover them. Let's introduce an error into our indent file, indent source. Here I'm checking if tab is actually tab, and it seems it is, but let's double check. So here I have spaces and I added one tab. So we have this ununiform indentation. We need file system to read our content from the file. Another immediately invoked function with async, so we can await the file contents. And let's call our parser on the content of the file. We must move this below because this is a constant, not a function keyword. It would work if it was a function key. And here I have an error. Line 6 doesn't have uniform indentation, just as other lines don't. And that is a problem. Not all lines are ununiform. Let's debug it quickly. Try to find an error on your own. I'll quickly introduce some empty lines into our source. By looking through logs, I caught the first bug. Let's fix it. Line number is not starting from 0, but from 1. Unusual for programming, but it is what it is. Again I have a 0. What's happening? 0 is because my ununiform indent lines depend on index set, and it didn't add 1 on indexes. Here I'm still struggling to manually construct our indexes, but soon I will discover there is a much smarter way to do it. Instead of manually constructing those indexes, I'll just map them from already existing source, our tokens. Here is an excellent example of downfall of copy-paste programming. I copy-pasted one line, my regex line, and I forgot to change plus into a star. The only intruder now is line 1. It has 0 indentation, so it somehow got included. Let's fix that as well. I removed tab indent tokens and space indent tokens from set of all indexes, but I didn't remove no indent lines, so it got included. Let's first find no indent lines. Here is another regular expression, and let's include that array as well, and the problem is fixed. Fixed a bit too much. You can see there are no lines when I hover the variable. Instead of tweaking the regex, let's manually check if on position 1 is either a space or a tab. It's finally working. Only line 8 is fucked. And that's true. Let's remove the error. We don't need it anymore. When I run this, an error occurs. Our ununiform error. But it should not. So what's the problem? Length. Checking an array as a boolean is true, but checking a length of 0 is not. Finally, let's tell the user if he has both indent modes, go to Disneyland. Let's specify an indentation mode and reference our tokens through unified variable. Let's add more properties to our token. Spread the token and add the property. Exclamation assertion is safe because we have indented tokens, so there must be indent. Let's compute our indent step. How long is an indentation? Find all lengths. Those are 2, 4, and 6. That's nice. Now I should convert my set back to an array so I can call mat minimum. But then I figured out I can do this more cleanly. Map length from tokens and make set from lengths. And finally we have our step. Never mind my thinking went left and right, because I won't need the set. After all, lines that are not multiply of step don't have a valid indentation. So let's use that. This seems to be working. Smooth. No line includes both space and tab, and no line isn't a multiplication of step. So the first part of checking our indent level is done. Now it's left to check if all successive lines respect each other and their indentation level. In the process of doing that, we should store our indent source in a tree, because indentation language is a tree. But we don't have a tree data structure. So in part 2, we will create just that. We will create a tree structure, and once we have that, we will come back here and populate it